So I have gotten a lot of requests to do some stoichiometry walkthroughs. I took this question from Mr. Benson's stoichiometry booklet. 25.0 grams hydrogen sulfide reacts with 50.0 grams of potassium permanganate to produce potassium sulfate manganese fluoride oxide and hydrogen gas. Write the balanced chemical equation. There's supposed to be a comma here, just saying. Write the balanced chemical equation. Determine which reactant is limiting. Determine which reactant is in excess and by how much. And what mass of manganese fluoride oxide will be produced. And what would be the concentration of K2SO4 if the amount produced were dissolved in 1.5 liters of water. This is a lot of questions, so let's just start with A. So let's look at the compounds, the reactants first. Hydrogen sulfide, so that's just H, S. S is -2, so it has to be 2H, then plus potassium permanganate. So potassium is K. Permanganate is MnO4. Wait, MnO4. Yeah, MnO4. And that has a charge of -1. And K also has a charge of +1. So we just need to do this. And then it produces potassium sulfate, manganese fluoride oxide, and hydrogen gas. So potassium sulfate, that is K and S. K is +1, S is -2, so we now have to put a 2 on the K. And plus the second compound was manganese fluoride oxide. Manganese, M, N, and O. Oxygen is -2, manganese is +4, so we have to put a 2 on the O. And then one more, just hydrogen gas. So that is H2. Now for balancing, see there's 2K on this side, 1K on this side, so let's just put a 2 here. Now there's 2K, 2Mn, 1Mn here, so we have to put 2 here. And wait, let me just do it in a different color so it's easier to see. Blue. So here we have 2H, 1S, 2K, 2Mn, 8 oxygen, 2 times 4 is 8, then 4 here. Wait, I think I made a mistake. Did I? Yeah. This is such a weird reaction. Potassium sulfate, not sulfide. So that means, let's go back to black. SO4. Okay, SO4 is also -2, so the K is still 2. So K2SO4. Sorry. So let's go, where were we? 2K, and then 8O, so 4 oxygen here. 2 times 2 oxygen is 4 oxygen, 4 plus 4 is 8. So oxygens are balanced. And yeah, this is the final reaction equation. So we're done A. Now B, determine which reactant is limiting. So here, let's just draw a line under this. And how Mr. Benson does it he writes the values under each compound. So what we have is 25.0 grams of H2S and then 50.0 grams of KMNO4. So 25.0 grams under H2S, and was it 50? Yeah, 50.0 grams under the KMNO4. And what was the question? Determine which reactant is limiting. So for this, we need to calculate the moles of each one. This one takes a while, so let's start with H2S. So we have 25.0 grams H2S, and we have to multiply it by the mole ratio. Let's just write all our mole ratios up here in, say, green. H2S. 2H is H is 1.0, so 1.0 times 2 plus 1S. What is S? S is 32.1. 32.1 grams per mole. So 1.0 times 2, that's 2. 2 plus 32.1, that's 34.1. And then, wait, this is a pretty bad color. Let me just do something better. Let's do red. 34.1. Yeah, this is, oops, 0.1. And then, yeah, while we're at it, let's also do the KMNO4. So K potassium is 39.1 plus 1 manganese, 54.9. Oh, I forgot to write the units here. Grams per mole. Let me underline it. And then 4 oxygen. So oxygen is 16.0 times 4. So 39.1 plus 54.9 plus 16.0 times 4. Just put that into your calculator. I already did it, and it is 158. Wait, is it? Yeah, point 0 grams per mole. Yeah, I should try to hurry this up because this will take forever. Change it back to black. So now that we have the mole ratio, 34.1 grams per mole. We put that in. 1 mole on top over 34.1 grams. And we can cancel out the grams. 25, put that in your calculator, 25 divided by 34.1, 0.733. 337. This is moles of H2S. And then to find how much we need to fully react with this amount, we multiply by the mole ratio. So how many H2S per KMNO4, or how many KMNO4 per H2S? That is 2 KMNO4 over 1H2S. Can cross out the H2S, and all we have to do here is multiply what we already have in the calculator by 2, and it is 1.47 rounded up to 3 sig figs, and that is moles KMnO4. Then let's underline this. Let's underline this too, because both of these are important. And then next one, we have to do it for KMnO4, 50.0 grams, KMnO4, 4 times 1 mole, and it was 158 grams, I remember. 158.0 grams. Then equals, cross out the grams. So that's 50 divided by 158, 0.316 moles of KMnO4. This is important. Now multiply by the mole ratio. Same thing as this, except flipped over, so we can cancel out the KMnO4, H2S over 2 KMnO4. Now, all we need to do with this is divide it by 2. So take what you have in your calculator and do divide by 2. So 0.158 moles of H2S. Okay, I think that was the hardest part. Now that we have these, let's circle them. Let's use purple. Let's use a different color here. This one looks fine. This is what we have, and this is what we need. So let me write that on top. So this is how Mr. Benson does it. Have and need. Okay, and then what we do here, it's a cross. It's always crisscross. So we have 0.316 moles of KMnO4, but we need 1.47 moles of KMnO4. So this can't happen. But we have 0.733 moles of H2S, and we need 0.158 moles of H2S. So this is what actually happens. We do have enough to react fully with the KMnO4, but not fully with the H2S, because we don't have enough KMnO4 to fully react with the H2S. So that means KMnO4 is the limiting reagent. Oh, wrong color. So yeah, what question B asked? Determine which reactant is limiting. Yeah, so we're done question B, and we can move on to C. determine which reactant is in excess and by how much. So we just have to use our work from this one. Which reactant is in excess? So we take how much we have. Okay, so first of all, we know that the one in excess is not KMNO4 because it's limiting. So that means it has to be the other reactant, which is H2S. So what we do is this. Yeah, let's just write down H2S because that's half the answer. And then H2S, what we have to find what the excess is, we subtract what we need by what we have. So we have, what we have by what we need, sorry. 0.733. 0.733, that's what we have. Then minus 0.158. Yeah, put that in your calculator. 0.733 minus 0.158. 0.575. 75 moles of H2S. Now it asks for how much. This usually means that it wants the value in grams. So multiply by our mole ratio. Let's go back up and see what it is. 34.1 grams per mole. So times 34.1 grams over 1 mole equals, cross out the moles. Okay, multiply what you have in your calculator by 34.1. That gives us 19.6. And that is grams. And these are both the parts of our answer. We're done with that one. We're halfway there. D now. Oops. What is D? What mass of manganese 4 oxide will be produced? So this is our reaction. MnO2, that's manganese 4 oxide. How much will be produced? So to find this, we need to see how much, we need to take one of our reactants and make a mole ratio with that. So let's take our KMNO4. So 2KMNO4 over, oh wait, no, it's supposed to be on the bottom. 2MnO2 over 2KMnO4. Can cancel out the 2's right away. And we have to multiply by the amount of moles we're using to react. Amount of moles of KMnO4 that we're using to react to make MnO2. So that is 0.316 moles. And yeah, just pretend there's a KMnO4 here, so we cancel that out. Yeah, so it's just the same amount of moles, 0.316 moles of MnO2. Now asked for what mass. So yeah, we just multiply this by a new molar mass. Let's calculate that right here. Red MnO2 equals Mn is, let me see, 54.9 plus 16.0, which is oxygen, times 2 equals, I already wrote this down, 86.9 grams per mole. And then take that, put it down here. 86.9 goes on the top because we want to cancel out those moles. So take 0.316, multiply it by 86.9, and that would give us 27.3 sig figs, yeah, 3 sig figs, so 27.5 grams of MnO2. Let's circle that. And now we're on to our last question. What would be the concentration of K2SO4 if the amount produced were dissolved in 1.5 liters of water? Let's write that right here. E. Okay, so concentration, that's molarity. So remember the molarity formula. Molarity equals moles per liter. And we have the moles. It is, wait, do we? Oh, no, we don't. So let's do what we did for question D. Take the 0.316 moles of KMnO4, then multiply it by the mole ratio. So there is 1 K2SO4 produced for every 2 KMnO4. So we write that 1 KSO4 per 2 KMnO4. Cancel out these compound, then put in 0.316, divide by 2, equals 0.158 moles of K, wait, is it? Oh, it's K2SO4, I forgot to write that here. K2SO4. Oh, this isn't our answer, so I don't need to circle it. Yeah, so we have the moles of K2SO4, and we have the liters, so we just need to plug it in. So 0.158 moles per 1.5 liters. Put that in your calculator. 0.158 divided by 1.5. That's 0.10533. But pay attention, this one isn't 3 sig figs because we have 1.5 liters, which is 2 sig figs. So 0.1053333 to 2 sig figs is 0.11. 0.11 molarity of K2SO4. 4. And we are finally done. Hopefully this didn't take too long. These questions take a lot of time and effort. So let me know if you want to see another video. Thanks for watching.